Welcome everybody. My name is Henrik Burvang. I work as a Research and Innovation Manager here at Vard Design. Today we will present a research project called Piezo. It's short for a Plug-In Electric Zero-Emission Offshore vessel, and it's a project we have been working on since 2020. We are now ready with our results from the project and have the pleasure to show some of this for you today. So the project started in 2020. It's a cooperation between SINTEF, Vard, Solstad Offshore, Equinor, Corvus Energy, and supported by Forskningsrådet, innovation project for business. That might be a wrong translation, but anyhow. So this is a schematic overview of what we have done in the project. We have started with onboard measurements, a big logging campaign on a Solstad PSV. We have used this data to analyze, produce machine learning models, and to get an in-depth understanding on the operations and the energy consumption in this PSV. Further, we have built up a digital simulation twin with dynamic simulations on the energy system on board. So this simulation model is validated with the logging data and the machine learning model we created together with SINTEF. The last months we have been working hard to take this knowledge and use this model to put together a brand new design for a PSV, a battery electric PSV, and this is the concept we are about to show you today. So the premise for the design is that we have discussed these premises with Equinor and Solstad in order to see what we can adjust in order to reduce the energy consumption, basically. We have developed a design with slower transit speeds than normal, less deck area, less dead weight, no Uro, and we have reduced the accommodation size. We will go straight to the results before we show you a bit more about the actual studies we have done in the project. So our design is for a PSV with 16 megawatt hours of Corvus Blue Whale batteries. We achieve over 80% annual CO2 reductions. We have a relatively small vessel, bit less deck area than conventional PSVs, and we have a smaller accommodation with 14 persons for crew. We have reduced also one deck to achieve a smaller accommodation area. Yeah. This is how the design looks like. And now my colleague Tim Mack, who has built up the digital simulation twin, will tell you a bit about what we have done in these studies.
Okay, thanks Henrik. Okay, so to come up with the results, I have first built a parametric model fully parametric hull form, and then I've added the subdivisions to include the cargo tanks, automatically model the battery capacity, and that makes it simple to do design variations and optimizations. So we can quickly adjust the hull form, change the length, and we get an updated battery size, dependent on the and cargo capacity as well. And that I've connected this model up to our CFD tools, so I'm able to predict the resistance using an automatic pipeline through the connection between cases, our parametric modeling tool, which also allows us to do design optimization. For this study, I've just changed the length, the beam, and the speeds. And next step, from this resistance model, I've generated a surrogate model, which enables me to quickly calculate the resistance for any design alternative within this design space that I've already got. And the next, part of the simulation, of course, is the system simulation, which I've conducted in AIM-Sim, and this includes models of the thrusters, the propulsion system, wind resistance, added wave resistance, battery systems, the alternative backup power generation plant, and hotel loads, as well as DP loads when we're on DP for recharging. And you can see in the next slide, this is shows the route that we have simulated. We're starting at Mogstad, we sail out to the OSS, the ocean charging station, recharge the vessel up to 80% state of charge, and then continue around the troll platforms A, B, and C before we recharge again. And this next slide shows an example of the results with energy consumption over 1 year. We have all the voyages along the x-axis and the energy consumption along the y-axis, and this is just an example of simulations which run for each day of 2020 using hindcast data. So we take into account the waves, the wind, directions, and all that to get as good an estimate as we can. There's a little bit, you can see a little bit of variation. We get the blue and some grey tone. That's where we have to adjust to be tested at different hotel loads. So we can simulate the effect of different hotel loads on the simulation. Because all the tools are integrated, it's very simple to test different configurations. I've tested so far over 50 configurations of hull, cargo, ship, speed, so together looking at over 18,000 separate voyages simulated. Yeah. And this is the quick results. You can see along the x-axis at the bottom the gross battery energy and the reduction in fuel, or the total compared with the same vessel running on diesel. So you can see for 16 megawatt hours we can reduce the fuel consumption by over 80%. So quite a few dots down there because I've tested out different battery sizes, different hotel loads, and all that. Okay. So just a quick snippet of the results. Hand it back to Henry.
Okay. Thank you very much, Tim. I think it's also important for us to stress that we have not, the solution we have chosen in this concept is not the limit for our design. It's scalable to different operations, but we have chosen a setup which we think is the most optimal one for the operation we have simulated, and also the most cost efficient. we have done some cost assessment for the case as well, comparing this battery electric Piezo case to some other relevant options. We have one case with compressed hydrogen and fuel cells. We have another case with a pure MGO solution. So this cost assessment includes relevant CapEx costs and relevant OpEx costs as well, including Norwegian CO2 tax. We have done some assumptions, of course, on the pricing and some conditions which we think are fair, and we put up the most important assumptions here. So, promising results cost-wise. We see that the accumulated costs over a 20-year period for the Piezo concept is significantly lower than actually the MGO solution, and for this case the hydrogen solution as well. Net present value assessment with a 7% discount rate indicates that this Piezo concept for this operation would be 27% cheaper than compressed hydrogen solution and 25% cheaper than MGO. So it's a good investment, but it's not only a good investment in terms of economics. We have achieved drastic CO2 reductions, and we have a significantly higher system efficiency on this solution than the options as well. So both economically and environmentally, this is a sound investment. So a final thanks to our partners in the project. It's been a very fruitful cooperation through 3 years of research. Solstad Offshore has made their vessel available to us. We appreciate that. Equinor has come with great insight and guidance along the way. Corvus Energy, as a battery specialist, has been good to assess different solutions with, and finally, of course, Sintef, who have been very valuable for the research part. So in 2019 we had a vision when we applied for this project, and we stated a vision that we had a vision of a fleet of plug-in electric PSVs or OSVs sailing emission-free and charging offshore and onshore. That was 2019. Today in 2023 we still think our vision is highly valid, and we are accelerating our efforts in making this a reality. We are doing accelerated research on remote operations. We are developing our zero-class designs. We have recently started a new research project named Ich0, where we will investigate more into the HVAC and hotel loads, which has been lack in insight for many years, and we are investing very much in the ocean charger and doing research on that as we speak. So with that, we hope we will be able to enable sustainable business at sea for the future. Thank you.